Welcome, everybody. This is our first podcast, and did we come up with a name for the podcast?
Yeah, I was gonna say we haven't even came up with a name yet.
Name that we're gonna pick.
Podcast One.
Podcast One. Is that the name of it?
No, we'll think of a better name. I think it'll come eventually. We have to just let it flow out.
Let it flow. Let it flow. Let it flow. Okay, cool. So I guess we'll start with a little bit of an introduction and why we're here, why we're doing this podcast, and then we'll continue on with the actual meat and potatoes of the podcast. So
yeah.
I'm Victor. I've been a developer for over 20 years. I started back in 1993. Back before Windows. And this was back in the days of MS-DOS. And so MS-DOS, I don't know if anybody knows about that, but if you open up a command, that used to be your whole computer. That was it. You didn't get anything else, you know.
Back before it was all fancy and all that stuff.
Graphics. I mean, graphics were, it was 80 pixels by 25 pixels. So that's what you had to work with. You had those pixels to work with. And yeah, it used to be the old CRT monitors, the big ones, the what is it? The 3x4 or 4x6.
Yeah, just like a big old rock kind of thing, basically. Yeah. Just a big old rock.
It was huge. Yeah, definitely. So what do I do for a living? I work as a software engineer, and I don't like to mention the companies because there's just too many to list. I've contracted most of my life and held a couple of full-time positions here and there. So I'll skip the whole company thing. That's not a big deal about it. But some of the things that I've done is enterprise level web development. So think of shopping carts like Amazon, things like, content management. So, you know, if you go look at a blog and people uploading their content, but just at an enterprise level. I've done what they call ETL, which is called extract, transfer, and load, which means that you take data from one format, suck it into a program, munch it up, and then spit it out in another format. So I can take a text file and turn it into an Excel file, or take an XML file, turn it into a comma delimited file, filter, extract data, all that good stuff. What else have I done? Services. I mean, these are just little programs that run in the background of your machine. You don't even know that they're running. They're just running. There's tons of applications that are running in the background that people don't even know. Say, for example, the recording on this video, it's running in the background as you and I are talking. And so that's somewhat of a background service that's just capturing the video and the audio and converting it to a file. What else have I done? Infomercial fulfillment. I mean, order taking, processing credit cards in a mass level. More multi-level marketing companies, companies that work with auto sales and auto dealerships and valuations and stuff like that. Just all kind of good stuff. And so accounting packages, HR packages, and everything that everybody can't take something right off the shelf and plug it into their computer and run with it because they got such a big specialized company that you can't. There's no way that you can take an off the shelf product and fit it into a big enterprise level company. So they might start with that, but then we modify it, or we might just start from scratch because they started before something was off the shelf and they became the off the shelf product. There's all kind of good stuff.
It sounds like you should be like a math whiz by how much like accounting and like computer stuff you'd be doing.
Well, that's the thing is that, accountants work with math every day. If I work on an accounting package, I'm going to work with one formula one time and never look at it again because I've programmed it, and so it makes you like the worst person to really be an accountant because you don't practice all the different things that occur. It just, you write it and it's just something that's repetitive over and over and over, and you just never look at it again until it breaks or the requirements change or something, that requires you to modify the code. You look back, you'll sit there, you'll scratch your head.
What happened?
What was this thing doing? And I'm sure that's the story of any software developer that's out there. You write something 6 months later, you have no idea how it works. You kind of have an idea of what it produces, but the internals, you're like, yeah, I don't know. It's like I got to look at the code and figure it out. So, let me talk about what got me into software development. I actually stumbled across this field. It wasn't anything that was planned. I actually wanted to get into the medical field. I wanted to use respiratory therapy as a stepping stone into becoming something in the medical field, whether it was a doctor, a registered nurse. I didn't know. I just wanted to get into the medical field. But as I was working more and more, I just kept on getting deeper and deeper into computers. And in reality, to me, I hated it because that's not what I wanted to do, and it wasn't until when C# came out that I realized it's like, hey, this is an actual career, and some of the people that I met and that I learned from were like really smart people. And I was like, I want to be smart like them. It's like, I want to be able to solve problems like these guys do, and I think that's when I started liking it. But originally I stumbled upon it. And when I say I hated it, it's not that I hated the work. I hated the fact that I couldn't focus on what I really wanted to do because this is such a demanding career. It requires research. It requires learning, continuous learning. You're learning for the rest of your life because technology just changes so fast, but yeah, that's what I mean by hate, is that I wanted to do something else, but it was keeping me from doing what I wanted to do. And around 2001 is when I realized, it's like, wait a second, this is an actual career. I'm actually doing something that is worthwhile and I'm solving problems. And so, I embraced it and just ran with it, just like, okay, this is it. This, drop the medical field, and let's just focus on computers and keep going with that. And so, what's kept me in it? The continuous challenges. I mean, just there isn't a year that goes by where some new technology just takes the industry by storm. 3 years ago, it was Angular. Angular had this thing where everybody was learning Angular, the way that the websites were created. And then like a year and a half later, React came and it just took the internet by storm. Everybody needed to start learning React, and every website that you build, it was going to be React. And then right around the same time, maybe 6 months later, AWS, it started taking the internet by storm. And now we have Azure Devops. Azure Devops, everybody's like, all enterprise level businesses are utilizing Azure Devops, which is a cloud-based hosting system where you can host anything. You can host a file system. You can host a virtual machine, which running Windows, running Linux. They host it for you. You don't have to buy hardware and host it at your house. You pay a subscription and you get a certain allowance for free. And so there's certain things that they don't charge you for. You can run a database, you can run a website. I mean, there's, it's all hosted for you, and they call it cloud hosting, and cloud just basically means it's somebody else's machine, And so you don't know where it's located, and they say it's on the cloud. Don't worry about it. So yeah, that's me in a nutshell. I guess we can give the, whoever decides to listen to our podcast the opportunity to post questions, I guess, somewhere. Mm-hmm. And, we'll monitor them and we'll answer those questions, and we'll post them right back to reference the podcast. And so somehow or other. But let's talk about you, Jonathan.
All right. Yeah, so I am Jonathan, and you are my dad, obviously. But yeah,
Yeah, you don't look like me. You have hair.
we're kind of wearing matching shirts, though. Kind of
Yeah,
cool.
we are. Yeah, yeah.
Match today.
Yeah.
um,
We both wear glasses, huh?
so yeah, I am a graduate of college. I graduated with a plant science degree, kind of off this topic, but yeah. And
Something that I encouraged you to do. I said, you know what? Go get a degree. I don't care what it's in, just go get a degree. It is like, and that's what you did.
yeah,
Yeah,
that's what I did.
that's
And
good.
it's something that I am passionate about. Like I do care about plants, and yeah, I feel like they're going to be a part of my life all the time.
Yeah,
um,
definitely.
and yeah, and then I'll move on to what I do for a living right now. I kind of do well. I work for a restaurant, and I kind of do a little bit of everything there, except cook. That's the only thing I don't do. But I do kind of like odds and ends kind of thing. It's just like inventory. I do server stuff, and I also kind of like do social media on the restaurant too. Work with cameras. I do photography, videography for some things, and then I also work on the website, which is hosted on WordPress. Pretty basic, beginner level computer stuff that I'm doing, but it is kind of related. And yeah, that's what I do for work.
Very cool. Very cool. And what got you interested in the software development?
It was kind of the beginning of last year. The pandemic hit and everything kind of went to online, and so did my work. So we kind of built our website from there and built a kind of like an online shop. And I was part of that. Took pictures, literally did everything from scratch. Just hard work and a lot of learning on our end. And then yeah, I just started helping out with the website more and more, and still doing other restaurant stuff like server and barista stuff. Half and half, like that's literally I run back and forth doing both things. So yeah, I enjoy doing that. And then all of a sudden my dad mentioned, hey, I could teach you what I know. And now here I am learning programming too.
Nice, nice. What what have you learned so far? What kind of stuff you've done to do learning?
um, what kind of stuff I've done? I've just done a lot of well, right now I'm on Bootstrap. I'm learning how to build a couple easy websites from there.
But wait, where did you start?
I started with like basic CSS, JavaScript, and HTML. Just really basic stuff. Learning what each like labels, learning all the labels, and learning different codes and all that stuff. Just kind of like yeah, I feel like I just learned the terms basically, and then built off from there. Like that's pretty much how the learning goes. You just build off, and they all come together as one and make a cool website that does all kinds of things when you click on it.
Cool. And what kept you interested and continue to learn?
I feel like it's like the problem solving, like you said. It's kind of like challenging. It keeps you challenged, keeps you on the toes, and just learning about how a computer works. It's kind of cool. I like it. It's yeah, the problem solving aspect. I like solving problems, and computers are kind of like the way the future is going to be. So that's what's kept me going too.
Yeah, that's the same statement I've heard for 20 years. Computers are the future. They've definitely evolved, and so it just keeps on evolving and growing and stuff. So yeah, no, I definitely agree with you on all that. So let me ask you a question.
Mhm.
What is one of the common structures that you see in what you've learned. So you've learned HTML, you've learned CSS, and you've learned JavaScript.
Mm-hmm.
What is common among each one of those pieces of technology when you're writing it?
When you're writing it?
Yeah. So if you're writing, let's just take HTML first, right?
Mm-hmm.
HTML, you have a tag, right? Which it's a beginning tag, and then that, or the opening tag, I should say, and then that opening tag has a closing tag, right?
Mm-hmm.
And then you have CSS, and CSS, each class that you do has an opening bracket,
yeah,
closing bracket, right? And then JavaScript also has the opening bracket and the closing bracket,
mm-hmm.
depending on where you're using it, right? Like
Mm-hmm.
you could be creating an object, or you can use it inside of a function, or maybe on an if statement, or some kind of, while statement and stuff like that.
Mm-hmm.
But the commonality is there's an opening tag, something that says, hey, here's where it starts.
Mm-hmm.
And then there's some kind of closing tag, or some kind of closing, I'll call them a token, because there's openings and closing tokens.
Mm-hmm.
HTML has an open and closing tag. Classes in CSS have open and closing brackets, and then JavaScript is the same, right? You have the open and closing brackets for functions and objects and all that stuff. And so that's kind of the common thing, right? Mm-hmm. So I just wanted to point that out, because as we go into talking about programming and server languages, and we'll talk a little bit about this podcast's next 12 weeks, what we're going to be covering. But that same theme carries throughout every single programming language that's out there, whether it's C, C++, Java, C#, Python, Ruby, Perl. They all have something that starts, a method, a class, an object, and something that indicates, hey, here's the end of it. It could be a space. There's always some kind of token. There's something in common there, And so
I didn't really realize that, but it makes sense to have that in a code, because you need to know when it finishes, even though you have like a bunch of different tokens inside tokens, I guess you could say.
Yeah, exactly. And that's not for the human.
Mm-hmm.
For the human, that's not what those tokens are for. It's for the actual compiler, for the machine, when it interprets that into, whether it's a little blinking pixel on your monitor, or saving a file or something. It's for the computer to know where something starts and where something ends. The human readability aspect is the fact that we start on one line and we end it on another line. And then in the middle is all the stuff that you needed to do, right? HTML, you introduce a body, and then inside of a body, you might put a div, and inside the div, you might put a p tag. And each one of those has a beginning and an end. And some of them are considered self-closing, so it self-closes. It doesn't have two of them. It just has one, but there's like a / that tells it, hey, we don't have an ending tag because this is just a self-closing tag. But the reason we format it in such a way that, we nest them and indent them is for the human. But you can put it all in one line, and the machine looks at the beginning and ending, if you put it on one line. So really it's for the compiler. The format is for the human so that we can read it. Mm-hmm. But for the machine, it doesn't care that it's on one line or on multiple lines. It just looks for those tokens as you're dealing with different programming language. I wanted to point that out, because it is such an eye-opener when you realize that. You're like, holy cow. It's like, this makes it simple to understand every single programming language. It's like, where's the end? Where's the beginning? Vice versa. And I should say, where's the beginning? Where's the end? and this encompasses, and what are the rules for that programming language, and granted, HTML is pretty basic, pretty easy, but it introduces you to that structure. Once you move into CSS classes, you get that same structure, but they have a different job. Once you go into JavaScript, now you have some logic that runs, in steps.
Mm-hmm.
And then there's rules within that logic, within those brackets, right? Within those starting tokens and ending tokens of what happens in between. There's certain rules that are being followed. And that applies to every programming language. Every programming language will have some kind of starting token, will have some kind of ending token, whether it's a blank line, whether it's, indented, common indenting of the program, stuff like that. But the problem is that there are certain rules that need to be followed within those starting and ending tokens. HTML has the rules, CSS has its rules, JavaScript has the rules, and as we start getting into C#, it's going to have its rules. So just those are really important. And if you can accept that as something that a machine just needs, and we indented for the human, then all you need to do is adapt to the rules, and you're good to go with any programming language, whether it's going to be C, C++, Java, C#, Python, Perl, Ruby, whatever, Golang. They all have the same basic structure, but they all have different rules that apply within the starting and ending. And that's what you need to get used to, is all the rules behind all these different languages, but they all still need something that starts and indicates, hey, here's the start of something, and here's where this something ends, whether it's an object, whether it's a function, whether it's an object, a class, whatever. But that's the basic functionality behind, I would say, 99% all of programming languages, And granted, every programming language has its own functionality, We'll start with C, which is probably the closest thing that I can remember of something that's functional. C is used for embedded hardware. So if you take like a little chip or whatever, and you put that chip on a board, there's probably C code in that chip. Whoever wrote the logic for that chip, that's probably written in C. So there's no fancy UI, it's just some logic that runs in C. And the reason C is used, and we'll get more into this later, is because C is probably the closest language to the hardware than any other language. All other languages are pretty much abstracted. C++ is probably the next second closest. I'm sure there's others, and I'm not even going to pretend to know, what's what, because of the stuff that I've been doing. But just kind of with what I've learned in the last 20 years, that's kind of what these languages are. They specialize in something, and we'll get into that. So let's talk about what we're going to do for the next 12 weeks. And I actually have a surprise for you.
Okay. I'm excited.
So for the next 12 weeks, you've got a curriculum that you're working on right now. Mm-hmm. And I think now that you've learned HTML, now that you've learned CSS and you've learned JavaScript, and then we've taken CSS and JavaScript to the next level. And, I've had you go through and start learning Bootstrap, which kind of combines the two to really style the HTML and make it prettier, so that if you're not creative, Bootstrap is a perfect CSS framework that'll help you be creative. It's like, I am not a creative person. I'm not artistic. I'm more autistic than anything. I am not artistic at all. And so using a CSS framework like Bootstrap really helps come up with some designs that will at least present the functionality in a pleasant form, something that's pleasant to the eye, because a person who's not creative or artistic is not going to create anything that's pleasant to the eye. In fact, we're going to present something that's like, yeah, no, that's not what I was looking for. People who you solve problems for are very visual, and being able to do something in an artistic format by using frameworks like Bootstrap, it really helps. Bootstrap may not be the be-all, end-all answer to coming up with something that's user-friendly, creates a good user experience, but it's a great way to demonstrate. And that may be the final thing that you use, or you may end up having to customize some of the Bootstrap classes to fit what it is that you're doing. And so, but it's a great start. It's an absolute perfect start, and that may end up being what you write your application, your web application in, and just customize a couple things here and there. But we are actually going to be reading a book, and I'm going to have you follow that curriculum still. I think your next project that you're going to be working on involves learning React, if I'm not mistaken. But as we work on this podcast, I'm going to have you do some reading and following some of the examples in the book. And we're actually going to start at a very advanced level book, because with me helping you understand what it is that you're reading as you're learning C# is going to be, with this podcast, is probably going to help you accelerate and learn C# a lot quicker. And I think we could probably disclose the fact that that's the whole purpose of this podcast, is for anybody that wants to learn C#. We'll go ahead and post the book that we're going to be following along with. Well, you will. I've read plenty of books. I'm going to read it just so that I know what it is that you're reading, and be able to explain what it is that they're talking about at a very advanced level. And so that's really what this podcast is about.
Cool. I feel like I'm the perfect subject because I know nothing about C# right now at the moment.
Excellent. I love it. So from a 10,000 foot view, the goal of the next 12 weeks is to get a basic understanding of, obviously, an introduction, which we're going to do today, to .NET and C#. And this is without even you reading a book. I'm hoping to be able to deliver the content and help you understand it. Writing a program. So, this may come in the next couple of weeks. We're going to be learning about variables and expressions. We're going to be talking about flow control of the program. We'll take a deeper dive into variables once we finish up the flow control, because there's so much more once you put flow control into the mix. Then we'll talk about functions, and some of the best tools that come with C# is the debugging tools and error handling. Because I can tell you, no matter how long you've been developing, no matter how good a developer you are, your user is going to break your application. Whoever your user is, even if it's you're gonna break it. And you need to be able to handle that breakage in such a way that is not so much elegant. I want to say it's probably elegant, but in a way that will continue to work with your application and not have to restart it or cause some kind of catastrophic internet meltdown. And then we'll start getting into object-oriented programming, or what I have on the list as OOP. And so OOP. Object-oriented programming, it seems like it's a dying breed, but at the same time, there's a lot of object-oriented programming in frameworks. And so it's important when you have to debug a framework because you found a bug in somebody's code. It's like, oh my God, it's like these really smart people that are putting all this framework content out there, they wrote something wrong. It's like, that's normal. You know, it's like you're never going to be able to handle 100% of exceptional behavior. And that's what, you know, being able to handle exceptions. But there's so much object-oriented programming involved in frameworks that it's important for you to understand it in order to debug it. And so that's something that we're going to get into. And then with object-oriented programming, we'll get into defining classes. And then we'll get into, there's new rules that apply with variables that are inside of classes. Because now, even though they're variables, they're called members and stuff like that. And then we'll get into that. And then we'll get into some like miscellaneous stuff, things like collection, comparisons, conversions, because you can convert a sentence. You can extract the numbers from it and convert it into an integer or a numeric type. And so there's those types of conversions. But then there's rules about converting a decimal to like an integer, right? It's something that has decimal value. So like if you have $1.05 and you want to convert that to an integer, it's like you're just going to get $1. And they're like, hey, just so you know, you're going to lose 5 cents, you know? And so there's ways of converting those values in such a way that you tell the compiler, like, yeah, I know those 5 cents are going to get lost. I don't care. Just convert this to an integer type of thing. And there's reasons why you would do that. And so, but, you know, we'll get into that. And then we'll get into some, you know, semi-advanced topics. One of the advanced topics that I want to get into towards the end of the 12 weeks is generics. Generics. Imagine just taking any math formula and being able to say, go ahead and take these values and process the formula. Okay, well, you can do that with actual other types of data within your application. And so depending on those types, it'll behave in a certain way that, you know, you can make it do anything, any type of logic in a generic form, so that you can reuse more of the same code and don't have to rewrite that same code over and over just based on some type. You know, it's like, well, today I'm working with integers. Tomorrow I'm working with a sentence. The next day I'm working with some kind of, you know, Boolean value, which is just true and false. Like your application using generics will be able to handle all those different types without having to actually change your code. It just adapts based on the generic type that you're sending in. And that is a layman's explanation. It actually is a little bit more complicated than that, but just to kind of give you an idea of what generics are about. And then some of the more advanced topics are things like link and lambda. There's a misspelling. It auto-corrected. It actually is link. And the link is actually spelled L-I-N-Q. And so, and then anonymous methods. And I think that in ES6, ECMAScript 6, which is JavaScript 6, obviously, they do use what they call fat arrow functions. Did you learn about those?
Yeah.
So that's something similar that's in C#, and it's really, you're going to be finding it in a lot more languages. There's a lot of languages that are coming up with that same concept, and C# is no stranger to it. They're also doing that, except that they're calling it anonymous methods. You see, so you're already ahead of the game, Jonathan.
I just remember the symbol. Like, I mean, I don't remember how it used. I haven't done JavaScript in a minute. It's mostly been HTML. So
yeah. No, I hear you, because I haven't done React in a year, and I was thinking about like, I want to create a quick React application. And I was like, wait, how do I need to use the command line? That's right, the command line. That's what I need, you know? So there's so many things to learn that unless you're working on them every day, and I think that's the important thing, right? Is that you work on something every day, because if you don't use it, you lose it. Sorry for the cliche. But yeah, I mean, that's in a nutshell, that's the next 12 weeks.
Cool. Right.
Okay, so let's see. Let's go ahead and get into introduction to programming, right? And I got quite a few notes here. I'm going to try not to go directly off of my notes, but I'll try to explain some of the stuff as we go through it, right? Let's take JavaScript because you're familiar with JavaScript.
Mm-hmm.
JavaScript, you create a JS file, right?
Yeah.
And there's some logic in there. Or you can include it inside of a script tag in HTML, and it'll execute that from top to bottom, right?
Mm-hmm.
So program files are no different. You know, whether you're working with C, whether you're working with C++, C#, Java, you know, Ruby, Perl, Golang, it doesn't matter. There's some kind of extension to that program file. So C files are with the C extension. C++ program files are CPP. JavaScript have a Java extension. C# have a CS extension. JavaScript is JS. I don't know what Golang, what their extension is and stuff like that. But my point being is that you write your logic in a program, and what looks like some kind of quasi English language, right?
Mm-hmm.
I mean, you can almost read it
Mm-hmm.
and understand what it's doing, right?
Yeah, it's like just abbreviated words kind of thing. Yeah.
Exactly. And then that somehow gets turned into something that the computer understands, you know, into some kind of binary format. So it has to go through either some compilation that takes that quasi English language and turns it into something that's binary, something that's ones and zeros that the computer understands. And so that is a very short line of explanation. There is so much more going on, you know, that meets the eyes. The reason it kind of just seems like you're taking a file and you plug it in somewhere, and all of a sudden it's like your computer's doing something, you know, is because of the tooling that have been created. You know, Visual Studio Code, Chrome, you know, also takes your code and compiles it in some fashion. And so all these tools are built around your program file that actually convert it to binary, you know, and I hate to simplify it, but that's really what's happening. You know, you're really just, you write the program, you execute it in some environment. So let's take JavaScript, for example. You're going to execute it on the browser. You can also execute it inside of Node.js, right, which runs on the server. But the thing is that you're running it in some kind of environment. And that environment takes it and either compiles it or runs through every single line of code and interprets it into some kind of binary language that the computer understands. That's the short of it, right?
Mm-hmm.
You know, let's take a step back for a moment, and let's talk about modern programming. Okay, modern programming, really, the reason we see that straight line from program to binary is because there are so many abstractions. There's so many layers of abstractions. Let's go back to the 1960s for a moment, right? If you had a drive of some sort or some kind of memory module that stored memory or stored content for you, as you wrote the program, you had to know what commands to give that hard drive or whatever storage device. You had to know, excuse me, you had to know how to store a file or save something in memory or access. So you were communicating directly with the hardware. Well, with modern programming, you know, you'll have your motherboard, you'll have your memory modules, you'll have your hard drive, you'll have your keyboard, your mouse, your video card, your monitor. You'll have all that. And it doesn't matter what manufacturer makes it, there's something common that allows each one of those pieces to interact with each other. And what's common And granted, not every monitor works with every video card. You may have a VGA monitor that you'll need an adapter to work with, like some kind of, HDMI, connection. Or I forget some of the other connectors that exist. I mean, most of my stuff is on HDMI, so I don't really work with all these different connectors, But my point is that you don't have to worry about how the monitor connects, because whatever's going to be displayed is being handled by the operating system, right? So if you have your first layer of hardware, your second layer is going to be the operating system. And the way that the operating system communicates with every single one of those pieces of hardware is through drivers. So in most cases, if you have something advanced, like say, for example, some high performance graphics card, that graphics card comes with software, with drivers that the operating system needs in order to communicate with that high performing video card. Otherwise, you would have to program for each and every single video card that's out there. So wow. It abstracts you from that layer, okay? Mm-hmm. So now you have the operating system. Now, if you program in any programming language, let's go back to the 60s. Let's just say that they had the operating system that abstracted all the hardware, and you no longer had to program to the hardware, you program to the operating system. You still had to know what commands to execute on the operating system in order to make it do what you wanted to do. So if you needed to display something on the screen, you had to know how to command the operating system to command the video card that commanded your monitor to display something on the screen. Well, modern programming, Java, even C++, and C# and Python, Golang, all these programming languages, they have so you have your hardware layer, you have your operating system layer, and they have what they call a runtime layer. And that runtime is what you're programming to. So if you think about it, when you were changing a color mm-hmm. on an element or changing the content of an element, you didn't have to tell the operating system, and you definitely didn't have to tell your video card or your monitor to display something. Yeah. You told the runtime mm-hmm. that you needed to change something or change the content of something. And the runtime communicated with the operating system, which then communicates with the hardware to make it happen. So you can see in modern programming where you got all these layers of abstraction. And all these programming languages have the same thing. Even C has a small runtime that is needed. I think it's called CRT0 or something like that. I have it somewhere in my notes. But my point is that the actual runtime is what communicates with the operating system. So now you look at a language like C and C++ and Java and C# and Node.js, which runs JavaScript, and Python. Each one of those runtimes was developed to communicate to the operating system. So you could run a C# program on Windows, on Mac, on Linux, and who knows how many other operating systems. It's however many runtimes they've created. I'll name a few more: iOS for iPhone and Android. So mm-hmm. there's runtimes that actually run on all these different operating systems, so that you don't have to worry about every device and how what it is that you need your program to do. You tell the runtime, which then informs the operating system, which then informs the hardware, so on and so forth. So you get the layers of abstractions. Does that make sense?
Yeah, it does actually. Yeah, I didn't realize like how like detached everything was too. Like, yeah, it totally makes sense. Yeah.
Okay. So yeah. So when with JavaScript, did you get an opportunity to grab a file
No.
You didn't work with the file system? Okay. So yeah, so essentially, you don't have to worry a lot about like if you're going to save a file or if you're going to open a file to read the contents within your program. You don't have to worry about how to communicate with the hard drive. You just got to communicate with the runtime itself. Mm-hmm. And so the runtime, it'll look at like, oh, I'm running on Windows. So here's my commands to send to the operating system to tell it that I need to go and open up this file. And so the same thing with your keyboard and mouse, right? You don't have to sit there and write the logic that's going to sit there and listen for a keystroke or listen for a mouse movement or a mouse click. The operating system is doing that for you. Mm-hmm. And the operating system, there's a way that the runtime and the operating system hook into each other and they listen for events that occur. So in the case that somebody taps the keyboard, the operating system sends that event and say, hey, this letter was clicked, or the mouse was moved, or the mouse was clicked, or the screen was touched. The operating system handles those events for you and sends them. And all you need to do within your programming language, tell the runtime is like, hey, listen out for these keystrokes, or listen out for this mouse click, or listen for this. Because Linux, Mac, and Windows, they all handle those events differently. And in order for you not to have to learn at the operating system level how to handle those events, you just have to do it to the runtime.